AB is equal to BA is equal to the identity matrix, then we can say A is inverse of matrix B or B is inverse of matrix A. B inverse into B is nothing but identity matrix, which is AB whole inverse is equal to B inverse A inverse. For every matrix, if inverse of a matrix exists, it is always unique. That means there will be only one inverse for a given matrix. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. Here in this session, we are going to revise chapter number 3, Matrices. So before that, let us see the chapter-wise weightage. So now here, in this chapter, we'll be having one multiple choice question, one 3-mark question and one 5-mark question. So overall, you can expect 9 marks from this chapter. So basically, your 3-mark question will be on invertible matrices or skew and symmetric matrices. Now, 5-mark question will be on the operation on matrices. So, little part of theory you can expect for MCQ. Let's see the objective questions. First one, if A is a square matrix of order 3 cross 4, then each row of A has. Now, suppose if A is a matrix and it's of an order 3 cross 4, so that means it is 3 rows and 4 columns. Yes, so in this way, they are asking the question, each row contains the number of elements, whether it is 3, 4, 12 or 7. Usually, total number of elements is nothing but 3 4s are 12 elements. But here we can clearly say we have 1, 2, 3, 4 elements because 4 columns means there should be 4 elements. So, therefore, it contains 4 elements. Next, if a matrix has 8 elements, then total number of possible different order of matrices. What are the order of a matrices? That is number of rows and number of columns we can set if the matrix A contains 8 elements. So, it can be 1 row 8 columns, that is 1 cross 8, or 1 column and 8 rows. So, therefore, it can be 8 cross 1 or 4 2s are 4 rows and 2 columns or 2 4s are that is 2 rows and 4 columns. So, overall, there is 4 types of order we can make for matrix A. So, therefore, the option is correct. See here 8, 6, 4, 2. So, option C 4 is the correct answer. Next, we have if A is a symmetric as well as skew symmetric matrix, then A is diagonal, A is null matrix, A is unit matrix, A is triangular matrix. So, the only matrix which is both symmetric and skew symmetric is your null matrix. So, therefore, the correct option is A is a null matrix. Next, if A is a square matrix, then A minus A transpose is unit matrix, null matrix, skew symmetric, 0 matrix. So, usually we also denote A transpose by A dash. We have a theorem that if A and A dash is a transpose of matrix A, then A plus A dash is symmetric and A minus A dash will be skew symmetric. That means the difference of the matrix and its transpose will always give you skew symmetric matrix. So, therefore, option C is the correct answer. Next, we have matrices A and B will be inverse of each other only if AB is equal to BA, AB, BA is equal to 0, AB equals 0, BA equals I, AB equals BA equals I. We know from the relations and function, inverse of a function exists if the composition of 2 function gives you the identity function. So, in the same way, matrices here, if the product of 2 matrices is commutative as well as it gives you the identity matrix, then we can say the inverse exists. So, therefore, if AB is equal to BA is equal to the identity matrix, then we can say A is inverse of matrix B or B is inverse of matrix A. Thus, A inverse exists only if this condition satisfies. Now, let's take 3-mark question. So, the very first question we have here, for any square matrix A with real numbers, prove that A plus A dash is symmetric and A minus A dash is skew symmetric. So, let us prove this theorem now. So, let me consider B is equal to A plus A dash. We need to show that A plus A dash is symmetric. So when we transpose the given matrix and it gives the same matrix, then we say it as a symmetric matrix. That is, if A transpose is equal to A, then it is symmetric. So let us take the transpose of this matrix. So let me take the transpose on both left hand side as well as the right hand side. So here I'll get A plus A dash whole dash. So using the properties of symmetric matrices and transpose of a matrices, here I can write A dash plus A dash whole dash. So we know that transposing the same matrix twice will give you the matrix itself, that is A, so which is B dash. So what is A dash plus A? A dash plus A is nothing but B. So here you can see B dash is equal to B, or we can say A plus A dash whole dash is equal to A dash plus A, which is same as A plus A dash. So the transpose of the matrix is itself. So therefore A plus A dash is a symmetric matrix. Now let's see what is A minus A dash. Now a matrix is skew symmetric if its transpose is minus A. So let's take C is equal to A minus A dash. Let's take the transpose on both sides. A minus A dash whole dash. Using the property of transpose of a matrix, we can apply here A dash minus A dash whole dash, which is equal to A dash minus A. So we got C dash is equal to A dash minus A. I'll take the negative sign outside. So then I'll get it as A minus A dash. What is A minus A dash? It is actually C. So we are getting C dash is equal to minus C, or we can say this A minus A dash whole dash is minus of A minus A dash. So by the definition of your skew symmetric matrix, A minus A dash is a skew symmetric matrix. Hence proved. Next, express the following matrix as a sum of symmetric and skew symmetric. Now we know that any matrix A can be expressed in the form of P plus Q, where your P is half of A plus A dash and Q is half of A minus A dash, where P is symmetric and Q is skew symmetric. So using this theorem, we are going to express 3, 5, 0, minus 1 in the form of P and Q. So first, let us consider this as matrix A. So if matrix A is 3, 5, 0, 1, what is its transpose? A dash. It is 3, 5, 0, minus 1. Now let's find P. So P is equal to half of A plus A dash. That means we need to add these two matrices. So we will get 3 plus 3, 6, 5, 5, minus 1 is minus 2. So now here P, we'll get it as 3, 5 by 2, 5 by 2, minus 1. So this is your P. Now let's find Q. It is half of A minus A dash. That is the difference of these two matrices, which is 0. So 5 minus 0 is 5. 0 minus 5 is minus 5. Minus 1 minus of minus 1 becomes 0. So when you multiply half here, it is 0, 5 by 2, minus 5 by 2 and 0. So now we need to verify whether P is symmetric and Q is skew symmetric. So let's take P dash here. So P dash if you take means it is again 3, 5 by 2. So 5 by 2 minus 1. That is equal to P only. So therefore P is symmetric here. Let's check Q dash. Q dash is 0, minus 5 by 2, 5 by 2, 0. If I take negative from this matrix, then it is 0, 5 by 2, minus 5 by 2, 0. So which is equal to minus Q here. So clearly you can see Q dash is equal to minus Q. So therefore Q is skew symmetric. Now let's add these two because we got P as symmetric and Q as skew symmetric. Let's add them. P plus Q. So P we got it as 3, 5 by 2, 5 by 2, minus 1 plus Q is 0, 5 by 2, minus 5 by 2 and 0 here. So let's add them. P plus Q. So 3 plus 0 is 3. 5 by 2 plus 5 by 2 is 5. 5 by 2 minus 5 by 2 is 0. Minus 1 plus 0 is minus 1. What is this matrix? 3, 5, 0, minus 1. It is our matrix A. So this is equal to A. So therefore, we have expressed A as a sum of symmetric as well as skew symmetric matrix. So this is how you need to express the given matrix as a sum of symmetric and skew symmetric. Next. So we have a theorem here. Prove that inverse of a matrix, if it exists, is unique. That means for every matrix, if inverse of a matrix exists, it is always unique. That means there will be only one inverse for a given matrix. So let us consider A is matrix for which inverse exists. Okay, so let B and C are inverses of A. So my aim is to show that B is equal to C. That is to show that it is unique. That means B and C are same. According to the definition, if B is the inverse of A, then AB is equal to BA is equal to I. So let me consider this as equation 1. Again, according to the definition of inverse, if C is the inverse of A, then AC is equal to CA is equal to I. So let me consider this as equation 2. Also, we know that any matrix can also be written in the form of B into I. Now, using equation number 2. So instead of I will write B into AC. B into AC. So now here, instead of AC, here using the distributive property, I can write this in the form of BAC, because we know that the product of three matrices is associative. So now instead of BA, using equation 1, I'll write this as I into C. Now from here, we got B is equal to C. So clearly you can see the inverse of the matrices are equal now. That means there is only one inverse for a given matrix if it exists. So this is the proof for the given theorem. Next question. If A and B are invertible matrices of same order, then show that AB whole inverse is equal to B inverse A inverse. We know that if inverse of a matrix exists, and if A and B are inverse to each other, then AB is equal to I. So here I need to show that AB whole inverse. So that means the product of AB and its inverse, that is AB whole inverse, will be equal to I. Now let me pre-multiply A inverse on both sides. So let us multiply A inverse here. So we will get AB whole inverse is equal to A inverse into I. I'll use the associative property here. So A inverse A into B, AB whole inverse is equal to A inverse into I is A inverse itself. Now A inverse into A is identity. So we got AB whole inverse is equal to A inverse. I into B is B. So AB whole inverse is equal to A inverse. Now again I pre-multiply B inverse on both sides. So B inverse B, AB whole inverse is equal to A inverse, and here B inverse. So B inverse into B is nothing but identity matrix, which is AB whole inverse is equal to B inverse A inverse. Again, identity into any matrix is AB whole inverse is equal to B inverse A inverse. Hence, proved. Next, we'll move on for the 5-mark question. I said your 5-mark question will be on operation on matrices. So here is the first question. If matrix A is 1, 2, 3, 3 minus 2, 1, 4, 2, 1, then prove that A cube minus 23A minus 40 high. So here a matrix equation is given. We need to show that the resultant matrix is a null matrix. So here we need to find out what is A cube, what is 23A and 40 into I. Since the order of a matrix here is 3 cross 3, you should take the identity matrix in the form of 3 cross 3 itself. So before finding A cube, let us find A square. Now how to find A square? Multiplying the same matrix here. So while multiplying the matrix, be careful with the rows and columns. So I'm writing the matrix here. So A into A again. So 1, 2, 3, 3, minus 2, 1, 4, 2, 1. So let us recall how we are going to multiply this. We always take first row with all the 3 columns. So first row into first column. 1 ones are 1 plus 2 threes are 6 plus 3 fours are 12. So first column is done. Let's move on to the second column. 1 twos are 2 plus 2 twos are minus 4 plus 3 twos are 6. Next we are on to the last column. So 1 threes are 3 plus 2 ones are 2 plus 3 ones are 3. Now the first row with all the 3 columns is done. Let's move on to the second row. 3 ones are 3 plus minus 2 into 3 is minus 6 plus 1 fours are 4. 3 twos are 6 plus minus 2 into minus 2 is 4 plus 1 into 2 is 2. Next, 3 threes are 9 plus minus 2 into 1 minus 2 plus 1 ones are 1. Now with the last row with all the 3 columns, so 4 ones are 4 plus 2 threes are 6 plus 1 fours are 4. Next, 4 twos are 8 plus 2 into minus 2 minus 4 plus 1 into 2, 2. Next we have 4 threes are 12 plus 2 into 1, 2 plus 1 into 1, 1. So this completes the matrix multiplication. Now let us add these things. So 1 plus 6 plus 12 equals 19. Next here we have 2 minus 4 minus 2. Minus 2 plus 6 is 4. Next we have 3 plus 2 plus 3, which is 8. Next we have 3 minus 6 minus 3. Minus 3 plus 4 is 1. 6 plus 4, 10. 10 plus 2, 12. 9 minus 2 is 7. 7 plus 1, 8. Next we have 10, 14. Next we have 8 minus 4, 4. 4 plus 2, 6. 12 plus 2, 14. 14 plus 1, 15. So this is your A square. So after finding A square, we can find A cube. So A cube is A square into A. So we got A square as 19, 4, 8. Next we have 1, 12, 8. Next we have 14, 6, 15. Again with A, we are going to multiply. That is 1, 2, 3. 3 minus 2, 1. And the last row is 4, 2, 1. So using the product of matrices, A cube, again multiplying the first row with all the 3 columns, second row with all the 3 columns, and third row with all the 3 columns, and the resultant matrix will be 63, 46, 69, 69 minus 6, 23, 92, 46, 63. So this is our A cube. Now let us consider the equation. We have A cube minus 23A minus 40I. So consider A cube minus 23A minus 40I. So here A cube, we got it as 63, 46, 69, 69 minus 6, 23, 92, 46, 63. So we need to multiply 23 to A. So we have A here. I'm just multiplying 23. So we get 23 here. Again 23 twos are we'll get it as 46. Next, we have 23, 3s are, which is 69. Next again, 69 minus 46, 23, 92, 46, 23. Next, we need 40 into I. We know the identity matrix is 1, 0, 0, 0, 1, 0, 0, 0, 1. So, when you multiply 40, only 1 becomes 40 here. The rest of the things will be 0 again. Now, let's solve this. We have 63 minus 23, 40. 40 minus 40, 0. 46 minus 46, 0. 69 minus 69, 0. Similarly, for all the given values, if you do the evaluation or the simplification, the entire matrix will result with 0. So, therefore, this is the null matrix. Hence, we proved. Next question. If A is equal to 0, 6, 7, minus 6, 0, 8, 7, minus 8, 0, and B is 0, 1, 1, 1, 0, 2, 1, 2, 0, and C equals 2, minus 2, 3, calculate AC, BC, and also verify A plus B into C is equal to AC plus BC, which is the distributive property using matrices. So, here we need to find out the product of the matrices. We also have the sum of two matrices. So, let's check this. First, let us see what is A plus B. So, addition of two matrices means their order must be same. So, this is also 3 cross 3, 3 cross 3, we can add them. So, here we have 0 plus 0, 0, 6 plus 1, 7, 7 plus 1, 8, minus 6 plus 1, minus 5, 0 plus 0, 0, 8 plus 2, 10, 7 plus 1, 8, minus 8 plus 2, minus 6, 0 plus 0, 0. So, we got this one. Now, let me multiply C to this matrix because we need A plus B into C. So, for the same thing, I am multiplying matrix C. So, let me multiply matrix C here. What is this? 2 minus 2, 3. See, the second matrix is a column matrix. So, therefore, my answer will be column matrix again. So, therefore, here we can clearly see 0 2s are 0 plus 7 into minus 2 minus 14 plus 8 3s are 24. Next, minus 5 2 minus 10 plus 0 into minus 2 0 plus 10 3s are 30. Next, we have 8 2s are 16 minus 2 into minus 6 plus 12 plus 0. So, we got the value as 10, 20, 28. So, let us consider this as equation 1. Next, we need to multiply A into C. So, let's multiply A into C. So, what we'll get? A into C. So, 0 2s are 0. Next, 6 into minus 2 minus 12. 7 into 3, 21. Next, minus 6 into 2, minus 12. 0 into minus 2, 0. 8 3s are 24. Next, 7 2s are 14. Minus 8 into minus 2 plus 16 plus 0 into 3, 0. So, we got the value as minus 12 plus 21 is 9. Minus 12 plus 24 is 12. 14 plus 16 is 30. So, this is AC. Now, let's take BC, B into C, the product of these two matrices. So, we have only one column. So, again, one result, one column will get 0 2s are 0 plus 1 into minus 2, minus 2, 1 3s are 3. Next, 1 2s are 2 plus 0 plus 6. 1 2s are 2 minus 4 plus 0. So, we will get the value as 3 minus 2, which is 1, 2 plus 6, which is 8, 2 minus 4, which is minus 2. So, now let's take AC plus BC. When I take AC plus BC. Let's add the given matrices. So 9 plus 1 results to 10. 12 plus 8 results to 20. 30 minus 2 results to 28. So we have 10, 20, 28, which is same as A plus B into C. So therefore, we have concluded A plus B into C is equal to AC plus BC. Next question. If A is equal to minus 2, 4, 5, B is equal to 1, 3, minus 6, verify that AB whole dash is equal to B dash A dash. The question is on the transpose of a matrix. So now we need AB and its transpose. Let's find out AB. First row with all the 3 columns, we have only one element in the first row. Let's multiply with all the 3 columns separately. Minus 2 into 1, minus 2, then minus 6, then we'll get 12. Next, second row, 4 ones are 4, 4 3s are 12, 4 6s are 24. Next with 5, 5 ones are 5, 5 3s are 15, 5 6s are 30. So this is our AB. Now let's take AB whole transpose. Minus 2, 4, 5, minus 6, 12, 15, 12, minus 24, minus 30. So this is row and we are writing in column. So the row should be written in columns. So this is the transpose of the matrix AB. Now let's check B dash into A dash. So let's write what is B dash here as well as A dash. So we have B here, that is 1, 3, minus 6. It's a row matrix. So its transpose will be 1, 3, minus 6 as column. Next, A dash, it's a column matrix. So therefore, after transposing, it becomes a row matrix, that is minus 2, 4, 5. So let's multiply again B dash into A dash. So minus 2, 4, 5, minus 6, 12, 15, 12, 24, minus 30. So you can clearly see AB whole dash is same as B dash and A dash. Hence, the property is verified. So these are all the few important questions which you can practice for your examination. So we'll meet you in the next session. Until then, keep watching, keep learning and keep exploring. Thank you.